Okay, good morning, class. This is weekly update 7. You just finished global experiment optimization last week. And so some of the activities, I wanted to point out the ones I liked and talk about the calculations as well. So in the activities, the um, many of you did the one where you projected a region in the XY plane drawn on your journal and projected it up. And a couple of things there is that even if you drew, say, a perfect circle down there, when it comes up onto your hand, it's not going to be oriented flat like it was in the XY plane, right? Because it will come up here. Um, and yes, it's important just as you move that region R around, you would have noticed that the extrema always occur only two places. They're either on the boundary of your region. A lot of you had like a global min down here, if that was your region. If your region included a knuckle, then often that was a global max. And for that, often the region might have come around like this. And so this would have been a critical point. So critical points and boundary points, the only places you have to look. Um, so from that activity though, and from some of the calculations, I realized that there's a few of you that do need to review this. So again, options as usual, have many lifelines. If you want to do an office hour at any time with me or Chloe, visit Chloe in the math lab, visit any of the folks in the math lab, where hopefully this week you'll see with this next discussion, maybe you'll find someone else in class, a study buddy that you want to just be able to call right away, have a lifeline to. So if that's the case, if you feel like you're getting behind in some of your noting that in some of your assignments, let's take active steps now to clear those things up. Because remember, you just kind of keep on building. Okay, the optimization assignment, there were some really good ones here. The discussion of your ideas of how you want to attack that. So you have a plane and you want to find the point on this plane that is closest to the origin. And the first thing was that many of you like to think about this visually, and you graphed it, you got out Matplotlib 3D, and you saw, first of all, that the plane doesn't go through the origin. So we have to find something on here that does. So the origin is not the point. And a lot of you talked about visually doing it and then maybe a guess and check. And I really liked visually, a couple of you got to the place. I think Christy was one, talked about, well, there had to be this perpendicular property. Like it has to be the point perpendicular, point on the plane that's perpendicular. And let's see, I think it was Keegan talked about, well, she got that perpendicular property. Oh, and Cameron did too, from the fact that rather than thinking of a 3D plane, let's just make this a line in two space. And we're now back on the XY plane. There's a line you want to point has to have the perpendicular property. So they extended that, which is using one of our math models that we see works a lot. Let's see. A couple of you then talked, oh, and Liam also talked about that it had to be perpendicular. He also talked about a plane and then a perpendicular plane, and then you'd be looking at somewhere along that line of intersection, which was closest. Patrick talked about maybe thinking like to actually take a 3D printer and print this little part of the plane and maybe the origin there. Oh, Erin did visual, but she added a guess and check where she's like just visually looking at it, picked a point and got its distance, and then picked another point and got its distance. Okay, that one was better. And so it kept moving around. And then to take that idea, take Erin's guess and check a little bit, amp it up, was Grant, who did it iteratively. So he was visually picking some points, but then he was using like a midpoint between those and doing this iterative scheme that it was hopefully converging to the value that would be smallest. Who else? Oh, Olivia and Will both got to the place where similar to the perpendicular property, but they were then talking about a vector. And one thing you could do at the origin is imagine a vector. And if I make a vector of a certain length, and maybe it's like this, it doesn't quite hit it, and you have to sweep around. And so you increase it a little bit more, and it doesn't quite touch it until one that does touch it, and you want the one that just barely touches it. It's more of a guess and check, but you could do that in Calcplot 3D. Let's see. Oh, and that the reason I also noted Olivia and Will talking about vectors is that, oh, this might have been Keegan. Keegan actually went back to chapter 1 where we learned about a tangent plane and a normal vector, and we did learn a little bit about vectors in space. And that's really neat preview because in chapter 1 of book 3.5, coming kind of soon, we're going to learn quite a bit more about vectors. And so we'll be able to define a vector in space and then send it right through there and actually go a little further. Rather than just a vector, we can actually make the line that that vector lives on. And so we really want the place where the line intersects. So many of your ideas getting closer there to, we'll have another way to doing this problem in a bit. Several of you also talked about, I think this was Kelly, maybe Thomas, and Olivia. It sounded like this assignment was neat because I could see the different ways y'all think about problems. And Kelly mentioned that for her, she tends less to think visual, whereas like Dana May is like right on, always visual. Well, Kelly was like, I tend to think, algebraically. And so when she's doing this algebraically, she can't get out of her mind that, well, I actually already know how to do this. It's a constrained optimization or it's a Lagrange multiplier. And you're right. So if you're going to get onto, well, you have to this week do optimization part 2, you want to think about now actually solving it and the pros and cons of that. We have to know the techniques and be able to do the algebra and maybe not make an error with that. But you actually already know how to do this. It's either a constraint optimization problem. Your objective function is you're minimizing a distance. Then there's a constraint. The constraint is that you have to live on that plane. So you can push that constraint into the objective and you'll get a function you're trying to minimize. And you can also solve that once you've modeled it, just pushing it in there and doing it, reducing the number of variables, or you can do it as a Lagrange multiplier. So a couple ways to do it this week. And it seemed like good head starts on those were Kelly, Olivia, and Thomas. Okay, another thing, the CalcPlot 3D, many of you were talking about that. I don't know if there's a way to like grab what's on your screen and export it, but what I always do is just a screen capture. So a screenshot on my Mac was Apple Shift 4, Apple Shift 5. So whatever computer you're using, figuring out how to use a screenshot, that'll help you with these kind of assignments, but also with your challenge problems. Let's see. Oh, then I'll show the screen and show a few of the what I put in samples and examples. So okay, so we were finishing up module 3, samples and examples for week 2. And so here's all the folks I put in there. Activities by Eleanor Griffin, calculations by Will, really nice tables that Will set up there. So if you're one of the folks that has trouble with calculations, check out and Grant's work, very thorough. Let's see, Grant's activities are nice. Dana May's, yeah, her calculations as well, step by step. Optimization planning document, I really like Dana May's and Keegan's. So those are 2 to check out. And then more activities, Patrick and Aaron, and also Aaron's calculations. So check out your colleagues' work, especially if you're one of the people that, again, there's a few of you keep submitting stuff and know that you're confused on certain sections. We'll go back and use this opportunity to look at your colleagues' work. And then also don't forget in the course materials section, I know many of you watch the videos and rewatch some videos, but there's ones that are particularly good down here. They're quite a bit long, right? But they're global extrema, finding those boundary points. So this would be one to go through. I've worked several examples in exhausting detail. That's why they're so long. And let's see, there's some more with CPs. So I think it's, some of you are starting to see where weaknesses from Calc 1 are cropping up. And so it's time to remedy those. But be efficient. Let's be smart about how we do that. Okay, and then last thing is this next time you're doing chapter 4. And we're finally getting away from derivatives now and doing integrals. That's the other half, right, of calculus. And so you'll be doing a lot of neat things with volumes. Okay, well, have fun this week. And please reach out with emails to Chloe and me and Chloe's sending an email with your grades. So check up on those. If you got any questions, keep shooting emails. All right, and good luck on all your midterms.